Okay, we're going to start 8.3. Before we go into 8.3, though, I actually want to go back to 8.2 for 1 second. Go back to 8.2. In 8.2, we started with defining a parallelogram. What is a parallelogram by definition? Kellen. Very good. A quadrilateral with opposite sides parallel. The first theorem we proved in that section, in section 8.2, what was it? Kara? Yes, and what does it say? Very good. If a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay? The next theorem in that section was what, Max? Okay, and what does that theorem say? Very good. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Molly, the next one. Okay, what does that say? Very good. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And Amber, one more. Okay, and what does that say? Very good. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Your homework that I'll be giving you later on in class, your homework tonight will come out of section 8.2. You will have to use those theorems to complete your homework. It's going to be application on those theorems. So keep that in mind tonight as you work on your assignment. You're going to need those theorems. Now, moving into 8.3. In 8.3, we're looking at the converses of those. So, all of those theorems in section 8.2, they all start off with what? What do all of those theorems start off with? If what? Christina? If a quadrilateral is a parallelogram. So, if I'm taking the converse of it, we're now proving what in section 8.3? What is it we're going to be proving, Keegan? That the quadrilateral is a parallelogram. Very good. So looking at the first theorem in 8.3. This is the converse to the opposite sides theorem in 8.2. It says, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, looking at this theorem as you're writing it down, what shape do we start with? According to this theorem, what shape do we start with? Christina? A quadrilateral. And what do we know about this quadrilateral, Daniela? The opposite sides are congruent. So, we know it's a quadrilateral. We know the opposite sides are congruent. So, Tyler, what can we say then about the quadrilateral? Then it's a parallelogram. It's the converse of what we did in 8.2. Looking at an if-then picture. The if part of this theorem, what will we draw? Go ahead, Tyler. Okay, very good. A quadrilateral with opposite sides congruent. So we'll do A, B, C, D, and we'll make the opposite sides congruent. So Killian, what am I given? The opposites. And very good. So we're given quadrilateral ABCD with AB congruent to CD and BC congruent to AD. Now, According to the theorem, if we have this, then what can we say? Brendan? No, according to the theorem, if we have this figure, then what can we say about it?
So we already have the theorem.
We're going to be proving this theorem, yes, but I'm saying in terms of this theorem, we're writing it in if-then form. And it's a parallelogram. Good. So the then picture. How do we represent this as a parallelogram? Colleen. What do I need to put on this picture in order to say, oh, this is a parallelogram? Yep. No, we do not know if the opposite angles are congruent, then it's a parallelogram. What will make this a parallelogram? Max. Yeah, we need these opposite sides to be parallel. Are you okay with that? Okay. So according to the theorem, if you have this, then we need to prove that ABCD is a what? We need to prove ABCD to be what? Tyler? A parallelogram. In order for ABCD to be a parallelogram, what do we need to have right before it? What do we need to prove about ABCD in order for it to be a parallelogram? Molly. What lines? Very good. We need to get the opposite sides parallel. So right before we can say this, we need to get the opposite sides to be parallel. Once we get the opposite sides parallel, then we can say that. So that's our goal, really, is get the opposite sides parallel. So let's start with our given. Okay. What proves lines parallel? Keegan. Good. Molly. Okay, co-interior angles. When co-interior angles are supplementary, the lines are parallel. Very good. What else proves lines parallel? Keegan. Corresponding angles. What do they have to be? Congruent. When corresponding angles are congruent, then the lines are parallel. What else does? Kara. Alternate interior angles. When they're congruent, the lines are parallel. What else, Amber? Alternate exterior. So, which one of those angles do we have up there? Colleen. Co-interior. All right, so we need to get B and A to be what then? Colleen. Supplementary, and we need to get B and C to be what, Max? Supplementary. Is everyone with me on that? Okay, now, what do we know about angle B and angle A? In order for them to be supplementary, they have to do what? Typically, yeah. Add to 180 or be a linear pair. They obviously aren't a linear pair, right? Because they aren't adjacent. So we have to get them to be add to equal 180. So, what do we know about B and A that we can get them to add to equal 180? Killian. You have a different idea? All right, I'll come back to you in 1 second. What do we know about B and A? They make up AB. Do we know anything else about AB, those two angles? Tyler? Correct answer there is no. So co-interior angles, can we use co-interior angles? They are co-interior, but can we use them? Because we don't. Can we say they're supplementary, Brendan? Let me ask it that way. No, we don't have enough information. So Killian, what's your idea? Oh, okay. Stretch it. Make it longer. Okay, because that's a segment. We could make it longer. I don't think that's going to help us, because now we're working outside of the parallelogram. Correct. We could make a linear pair. If I drew this line out here and called this E, we would then have a linear pair. These two would be supplementary, and so would these two, but we wouldn't know anything about these two angles on the tops there. Does that make sense, Killian? Okay. Kellen, what will that give us? Triangles, and what else? What type of angles? Kara, what type of angles? Yes, very good. Alternate interior.
I thought we weren't allowed to draw one.
On a test, you're not allowed to draw an auxiliary line. In class, though, yes. Now, what type of line is AC? This is a definition I gave you earlier in the chapter. Keegan.
Diagonal.
Yes, very good. So we're going to draw a diagonal AC. And what's the justification for that? Yes, Keegan. Extra line.
Auxiliary line.
No, it's not a definition on auxiliary line. That's not a justification. Well, actually, Keegan just said it. That's why I was calling on him.
What?
What's the justification? Definition of a diagonal. Very good.
What's the extra line?
An auxiliary line. But it's not. That's not a justification. It all depends. It all depends on how you drew. Like if you drew it parallel to something, we could use the parallel postulate. That was one we used frequently. Was the parallel postulate? Yes, Brendan. AC is congruent to AC. Why? Good. Next step. Keegan.
Triangle ABC is congruent to triangle ABC.
Okay, why are those two triangles congruent? Colleen. Yeah, we have side, side, side. Triangle ABC is congruent to triangle CDA. Side, side, side. Now that those triangles are congruent, what do we know? Amber. Which angles? We're trying to get these two lines here to be parallel. We're trying to get BC and AD to be parallel. Well, B and D are congruent because of triangles, but what other angles? B and D aren't going to help us get these lines parallel. I'm sorry, what? Supplementary angles are do you even hear what you're saying? Back up. To get these lines, we drew this line here. What type of angles did we create when we drew this line CA? Alternate interior. Can you tell me what the alternate interior angles are? BCA and DAC. Good. If these two triangles are congruent, what are these two angles going to be? Justification. CP what? CPCTC. So we know that BCA is now congruent to DAC, CPCTC. Angle BCA congruent angle DAC, CPCTC. Okay? With these two angles being congruent, what now do we know? Molly. BC is parallel to AD. Very good justification. Alternate interior angles what? Not congruent, but converse. Yep. BC is parallel to AD. Okay, we got one parallel and it's parallel. Tyler, how can I get the other one? What type of angles are D and B? No, they aren't anything. Nope. Don't draw another line. What type of angles are BCA and CAD, Tyler? Alternate interior. What letter do they make? Alternate interior angles make what letter? A Z. Very good. What other Z is up there? Good. Those two angles are going to be what then? Why? No. CPCTC, because they're both in those two congruent triangles. So BAC is congruent to DCA. With those angles being congruent, what do we now know? Daniela. AB is parallel to CD. Why? Alternate one, sorry. Good. So AB is parallel to CD. Alternate interior angles converse. So we have the two opposite sides parallel. So what can we say now, Christina? ABCD is a parallelogram. Justification, Colleen. Very good definition of a parallelogram. There you go. Questions on that? Theorem 8.8. Yes. All the converses prove lines parallel. Here's the opposite angles converse. It says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, your assignment for tonight. .2, practice B. 8.2, practice B, numbers 1 through 9. And 12 through 19. So today, we did two theorems that prove what? Both these theorems prove what? Christina? Quadrilateral would be a parallelogram. If the opposite sides of a quadrilateral are congruent, then it's a parallelogram. If the opposite angles, that's what this theorem here says, if the opposite angles are congruent, then the quadrilateral is a parallelogram. Okay? Once again, your assignment, 8.2b, 1 to 9, 12 to 19.